Dan Choquette, Director of Cloud and Big Data Solutions at Dell. Our group is responsible for strategy, software development, solutions development for open source based solutions. So that falls specifically with the bailiwick of OpenStack, which you might have just heard a little bit about, and Hadoop. So a lot of what we're focused on, again, is providing solutions to our customers that are open source based. And with their aptitude and willingness to dive into open source solutions, we're there to provide assistance and leadership.
Jason.
Hi, I'm Jason Waxman, General Manager for the Cloud Infrastructure Group at Intel. So my focus and our team's focus is on products and technologies for large cloud data center customers, both how we can optimize current technologies today for the requirements, but also kind of planning the roadmap. What do we think the infrastructure requirements are going to be for infrastructure as a service or for big data solutions 3 to 5 years out?
Hi, my name is Jan Drake. I'm with the Walt Disney Company. I'm their principal cloud architect working in their strategic architecture group, charged with bringing next generation platforms to the businesses to execute on. Disney's actually like mostly a holding company. We have ABC, ESPN, Parks and Resorts, etc. And we kind of sit in the center, trying to bring technology solutions to those businesses. And you can kind of think of us as a managed service provider.
Hi, my name is Yael McGuire, and I'm part of the Open Compute Project. So this is a project that was started by Facebook last year in April. And the effort focuses on trying to open up technology in the data center space and create a community that's going to work together to innovate in that space. And I'm hoping to get as many of you involved as well in the future.
Hi, I'm Brandon Fears. I'm the Manager of Product Planning in the ISS Hyperscale Business Unit. So this business unit is there for a lot of the public cloud companies, and we also do pods for the data centers, for both the infrastructure, the hardware, and then the goals. What my team does is we work on the technology that we'll be bringing to market in about the next 18 to 36 months.
Thank you. So we have a kind of a mixture of end users and vendors here. So keep that in mind. I'm kind of curious, in the audience, are there service providers in the audience, or are we end user IT? Who's an end user IT person? Okay. How about a service provider? And more specifically, a cloud service provider, I guess. I don't know if that's a distinction anymore. Okay. Thank you. So my first question for these guys is the whole notion of open source hardware. You know, can you apply this open source model that's been so successful on the software side to hardware, and what does that mean for cloud computing? Whoever wants to take it first.
I'll take it first. Just to talk specifically about our strategy, so our group develops software that assists companies to adopt open source software solutions, stacking and business. What we've also done with the software is we've open source components of what Dell's bringing to market as pertains to hardware configuration. A number of our customers are looking to adopt OpenStack and Hadoop are also interested in open source hardware because that is part of their technology strategy, not to be locked into a vendor's specific plans and hardware configurations and such. And that's probably one of the initiatives that we've done is to open source the blueprints around the Zeus product. So we see it as a trend. We're seeing some companies embrace it as part of their technology strategy. We're also seeing some companies that are waiting to see how it fully fleshes out.
And I think that there are some elements that absolutely can be applied, and there's some differences. So from the standpoint of the concept around open source, where I'm going to contribute some IP that allows people to go build off of it and kind of allow that sort of sharing back and forth to make the end result better, I think that as a concept absolutely can be applied. There are some certain flies in the ointment, such as that you could say the marginal cost of software is relatively close to zero. You know, at some point I can give you bits and allow you to apply them. There's a lot more cost that goes into manufacturing hardware, and as a result, it's the payoff essentially, sort of the ability to go ahead and combine sort of pools of IP and allow people to build off of it. It's a little bit different dynamic in hardware. And so one of the challenges is making sure that as we look at hardware, some of the principles of allowing people to kind of build off IP, agree on standards, some of these things that have kind of, been a part of the foundation for a while, we continue to build upon to that next level, but at the same time recognize that because there are real costs that go into manufacturing a PCB or silicon or whatever it might be, that there's some opportunity for companies who do put in that IP to recoup that, that investment. So some similarities, I think some differences.
So I look at the potential for cloud-enabled hardware, for OCP, et cetera, as an opportunity for, and I'm an enterprise, for enterprises to, over time, switch their model of actual hardware deployment and provisioning. And so what's interesting to me about the open nature of OpenC, OCP, and it is that it can represent a kind of paradigm shift from the tier one hardware solutions with support that we have today to simpler designs that are meant to be quickly swappable, less overhead, less maintenance, with the potential promise of reducing both support and hardware costs over time in a new model. And so that's to me the potential there. Some of the potential caveats there are, what do I have to do to my data center to support this, right? And am I locked into a rack design, or am I locked into anything, or do I have to retrain my people, all that kind of stuff? And I think those questions are still unanswered.
Well, I think from our perspective, we definitely believe that there's an opportunity here. I mean, I'm spending a significant amount of my time working on the notion of open hardware. And notice I've left out the word source there because that's something that's still a challenge. And I think Jason touched on this as well. I think this notion of the last stage where you take a design and you have to turn that into hardware, you need that entire infrastructure and ecosystem of players that are in the market today in order to enable that. You need HPs and Dells and some of these kind of stuff. Okay. So one of the things that I think that's really important in what we've done in creating this foundation, the Open Compute Project Foundation, is to pull together end users, suppliers, manufacturers, and vendors together to try to create kind of a holistic community that's going to focus together on trying to come up with both specifications. That's the area where we have been trying to be as open as possible. Designs, mechanical, electrical, and there's kind of a spectrum about how open people want to be on that, and that's something that we're all managing right now. And the process of other aspects, like just sharing information, just being able to talk about best practices around data centers and things like that, that level of openness, inviting people over to Facebook's data centers to look inside and see what's going on. There's varying degrees of what it means to do open source hardware design that we're all trying to figure out right now. And to me, I think it's a really exciting opportunity to explore.
Not to regurgitate what's already been said, we always used to joke that you wanted new code, you just take some Mountain Dew, take some Oreos, go to your favorite coder and, bribe them and say code like the wind and get it fixed, and take a day or two to get it fixed. Hardware isn't that simple. What we do see is these are new industry standards, or they will be applied to industry standards. I think one of the biggest challenges we see is, for example, what works at Open Compute for Facebook's data center. Sometimes we also have to go through all the regulatory agencies, and that's what really sometimes takes the longest amount of time to get some of these trends moving, because what works for one company, it's not that HP or Dell can go and sell that all across the world, because then we got to go to all the regulators, get that all approved, and it's like a bowl of spaghetti trying to figure that out sometimes, and to get that. And I think that's going to be one of the biggest challenges to helping these become more standards in the future, especially with, if you look at like OpenRack, great concept, but then, how do we get everybody on that power backplane? How do we get the regulators to all agree if we plug something in or Dell plugs something in? That's where the real challenge is going to be with Open Compute, or not Open Compute, but open source hardware type of initiatives.
Yeah, I couldn't agree more. That's one of the things that we're very interested in, to see how it flushes out. You see a similar thing with what OpenStack has gone through, where they've established the OpenStack Foundation, where the premise is to establish governance standards that all vendors can adhere to, be comfortable with, predetermined and/or discussed after the fact, and we can all, offer value and solutions to our customers along these lines. So customers can focus and be confident that, the consortium is going to, deliver what it promised.
I would love to hear some of the panel's thoughts on whether web-scale data centers are for everybody, or if there's where a scale-up appliance type thing might make more sense. I don't care who starts. We don't have to go right to left.
Well, yeah, one thing, the Open Compute project really is, and we've kind of defined a boundary of about 2.5 megawatts per year, that is the area where we're going to focus on above that big, right? But we do think that and hope that a lot of the innovations that come out of that effort will feed into what we think of as what we call the long tail. So enterprise companies who are below that range that could span a total aggregate volume that far exceeds the web scale companies. So we think that that's important. As far as kind of specialized vertical hardware, there's been an interesting development, and this was announced at our last summit in May, from the financial services community interested in hardware that would be targeted at their industries. And so Intel and AMD produced open designs for that specific industry that were motivated in part by some of the designs that came out of the Open Compute project. So there's this retargeting that is happening.
I'll give you my 2 cents on scale up versus scale up. So increasingly from a volume perspective, I think many more of the applications are going to scale out. I think for a lot of different reasons, but it really comes down to the application. But a lot of the things that drive a tremendous amount of scale tend to be large applications, high performance computing, or web tier types of applications, and they obviously consume a lot of servers. As a result, the volume of the market is moving towards a scale out type of model. And the thing that's nice about scale out, at least to a certain degree, assuming that you're not breaking your network and other sorts of elements to it, is that it's relatively cost effective to be able to scale. The things that still predominantly focus in on a scale up type of model are applications that benefit from a large shared memory type of space. There are certain, in-memory appliances, SAP, HANA is a good example. Databases. The other element is software licensing. Some of the policies for software licensing drive people to scale up. If you pay on a per server basis, it is very good for you to buy fewer but larger types of servers. And then I think the last element that drives people to scale up is manageability. But I think the more that we make the scale out servers more manageable, we take away some of that as a decision point.
I agree. We're obviously seeing both. We have a business that's committed to designing and delivering hardware that is for a specific workload. But we also have hardware that, quite frankly, is commodity hardware that's specifically designed for hyperscale type of environments that require, scaled out type of scenarios. I go back to OpenStack and Hadoop as examples where those are platforms that are designed to scale up. You want to add another node to your Hadoop cluster, you add it. You want to add another node to your OpenStack cluster, you add it. So it's again based on workload and based on what solutions you want to bring to your customers.
One thing that we've seen is customers will start breaking up the application. So the database, we're going to put these on these type of 2P servers. They're going to be workforce. They'll have some availability features. Web front end, we want this. So I think, but there's also a trend where I think a combination of both scale out and scale up. And what I mean by that is I've seen customers say, I only want for my web front end one boot drive, and if I only need one boot drive, let me put a 4-piece server there, and let me run that. Let me see how that works. So some of the customers I've seen experimenting with both. It's not a purpose-built appliance because most of the customers I've ever talked to, when you say the word appliance, that means I don't touch it, I don't do anything with it, they get scared, and they don't want to handle that. So I've seen a combination. I've seen, yes, we have a trend on scale out, but I think also depending on the customer, depending on the application, you could also see bigger, beefier boxes within certain segments. And you also have a trend with some customers saying, I want, Atom processors, I want to look at Atom or ARM in these different areas for, I don't need, I want to be able to use less energy. So I really see a combination of all three.
curious.
said.
That's all been said. I'm also curious about what you guys see in terms of software-defined networking and what that means for the future of the data center. What's going to change in terms of, well, just what's going to change and what it brings to the party.
So yeah, I'll jump in. So we look at the entire virtualized network space as a huge opportunity because we have many, many different properties that we, applications that we launch, sometimes up to 2 a day. The ability to actually completely encapsulate those within their own network and scale that local network, as well as move and extend that network across business boundaries, is a very powerful tool. So we're definitely looking at companies like Nicira and other companies to and open flow in order to enable.
I'll just add on top of it, I think there's just a tremendous amount of potential to solve real problems. And I think the two that I'm most interested in, first, sort of relating to virtual infrastructure, right? The ability to reconfigure VLANs and essentially create sort of this aggregation of switches, whether they're virtual switches, physical switches, and essentially creating a map that allows you to go reconfigure what your network looks like, particularly across cloud. I think it's got a huge amount of potential. And I think the other element is software-defined networking, which is beneficial. Actually, I had another one on top of this, but it's quality of service. Having the ability to do intelligent routing. One of the things that I hear from people today is I want to go to 10 gig, and you've got a certain amount of scale out, and then, oh gosh, now I reach a certain point where I can't over-provision anymore. If they had intelligent routing, they could do a better job of over-provisioning and bring down the cost of the networks. I think that's another element. And the third is just sheer programmability. Having the ability to just layer applications, whether they're security-based or compliance-based or workload routing and QoS. I mean, we hear people want to have more programmability in their network, just like they do on their servers. And I think all three of those have a huge potential from a software standpoint.
Yeah, plus there's a whole bunch of leverage there on the management side as well. One single place to go to configure your entire network.
We have a motto in our group where we say the cloud is never finished. And we believe that for the obvious reasons that as a service provider and or as an enterprise deploying a cloud, you're going to have different users. They're going to have different networking requirements. They're going to have different application requirements. They're going to want to introduce new hardware. And with that, obviously, is the fun of re-networking or networking them all together, whether it be VLANs or physical networking and such. And so with that said, we believe from an operational perspective, software-defined networking is huge. And again, going back to OpenStack, the Quantum project, companies like Indigo, Nicira, and Cisco doing some things as well. We believe that it's a great problem to solve. And from a vendor standpoint, if we can all collaborate and deliver that to the customer.
Where is the innovation coming from?
Well, I mean, from our perspective, it's across the entire industry. I mean, we put our efforts into technology, looking at where innovation's happening in the industry, and then trying to build up a community. We have a community of end users, vendors, consumers, and we see that there's tremendous interest in really getting down and focusing on trying to innovate where it matters, trying to focus on the problems that need to be solved right now, looking towards the future, and working together as a community. And I think that community aspect of in this space was somewhat lacking. And I think that that in itself is kind of innovation, as kind of a meta innovation concept, but there's very, very concrete things that are happening as well.
So you see hardware vendors like the people on the stage here building atop a higher, lower common denominator, basically, right?
Exactly. I mean, I think both of these companies demonstrated some really nice innovations for the Open Rack concept like just a couple of months ago, and we're starting to see a lot more that are coming down the pipe.
I think another example of innovation is companies like HP and Dell getting heavily involved in the open source community, whether it be OpenStack or what we've been doing with our Crowbar project, where we have a number of engineers that are writing code and contributing to the open source community. Whereas at this point, we don't have any plans for licensing it, so it's there for the public to use to stand up OpenStack in Hadoop environments in a a short period of time. But with that, and also as we, this will surprise probably some people in the audience, we've actually done some work with HP in this area because it's about driving adoption of open source products. And with that market increasing, it's better for everybody on this panel. So I guess just from a Dell perspective, hardware vendors writing open source software and hoping people contribute to it, I think is pretty fun.
One other point, it's not necessarily a specific company or anything like that, but it's kind of a bit contrary to this converged hardware. I think as far as the Open Compute project, we're focused on kind of the opposite, which is diverged hardware, which is disaggregation of hardware, separation of things like compute from storage, from power supplies, from data center racks and systems like that. And I think there seems to be a lot of momentum around that, so I'm kind of curious as to this maybe tension that exists between convergence and divergence.
I think Jan mentioned something earlier, like, is there a possibility of people being afraid of getting locked, customers getting locked into a rack versus some other, I mean, Jan, can you expand on that a little bit?
Well, one of the, so I guess the background to that is that part of our strategy going for the last 2 years and going forward is to prefer vendors and solutions that don't lock us in and allow us to change, because what we've recognized is that the rate of change of the market, the tool sets available, the innovation is such that we need shorter cycle times in terms of our refreshes for different capabilities. And so, in the data center, that's a lot more static. You have each kind of area that we invest in has a different, cycle of refresh, right? Hardware is typically 3 years. Data centers are much longer. But more specifically, when we look at, some of the emergent technologies out there that are actually kind of touch on that whole, on the whole scale out versus scale up thing, there's kind of an and solution there with some of the high density, low power compute chassis that are coming out by SeaMicro and others. I want to know that the stuff coming out of OpenRack, right, isn't going to preclude me from being able to apply those emergent trends, right, that are good for my business.
Any other questions from the audience, or I'll keep? Sure.
Yeah, I'm just curious on your thoughts on the whole kind of new way of building data centers. So you can have different types of open environments, and that means changing everything from even the air conditioning system that you use, so that you can start thinking differently about how you are actually implementing, these infrastructures inside these environments.
I'll try
I'm starting
to
to see that from places like Switch, which went through SuperNap, and how they've basically created a living kind of data center that allows them for a lot more flexibility in terms of what they have inside it. I'm wondering what your thoughts are on that.
I can jump in and sort of start. I think there's a lot of different elements to it. I think one of the first things I'd highlight is that with greenfield deployments and developments, there's a lot more degrees of freedom than there is with sort of a retrofit or existing data centers. One of the things someone told me last night that this surprised the heck out of me was that one of the hottest things right now, even above big data, which has a lot of hype around it, was DCIM. That infrastructure management in the data center and the integration of the facility and managing that with the power of the servers and the entire system is huge right now. There's a tremendous amount of need for information. So it shows that there's a clear trend that people are looking at. How do I treat it more like a living closed loop system, where I look at what workloads are being placed, the power that they're consuming, and then how to go modulate the cooling infrastructure. And by the way, those of you not familiar with the SuperNap, they have a 3-phase type of cooling approach, which includes evaporative cooling, free airflow, and also, additive cooling depending upon the type of environmental conditions. We also have been an advocate, even at Intel, of higher ambient temperature operations. So looking at ways, whether it's in the existing facility or in a new facility, how can you just run it hotter? We've been chilling the heck out of data centers and throwing cost out the window and consuming too much electricity. So I think people are really taking a hard look at it. A lot easier to do with new greenfield installations rather than trying to just retrofit. I mean, there are some things that still can be done, but that's where I think a lot of the innovation is coming from.
I think it was about 5 years ago that IBM did a test on one of the data centers and just shut off all the AC to see what the hardware failure was. something like 3%.
Yeah. And we, by the way, did that in New Mexico. We had to use real high-tech solutions, like for air filtering. We took like standard air conditioning, filters, and we can do a heck of a lot of stuff, but when you get a dry environment, even when it's pretty hot, you can do a decent job of cooling the infrastructure.
There's a great talk by Hamilton from Amazon about the best way to save your energy bills is to turn off the air conditioning because everybody's running things much colder than the ASHRAE standards, like by 10 degrees or something, right?
Yeah, and even the
maybe more.
standards they've been moving in the right direction.
More?
Yeah, 27 degrees.
But at the same time, it's really about how do we lower the OpEx? How do we lower the kilowatt hours being consumed within the data center? That's the goal. Whether it's free air, whether it's adiabatic, there's a lot of different cooling initiatives. Can we get, free air? Can we run warmer water in there? Can we raise the temperature? All that works. But at the same time, then you're going to invest more in the monitoring because if something does go wrong, things go wrong real fast across the board. So there is a balancing act that is the investment. And as Jason said, it is a lot harder in retrofits to do that correctly. There are some very innovative solutions out there with some modular data centers that help with that. But it comes down to you're going to have to do very good server monitoring. DCIM is a way, but there's also a lot on the facility side. And a lot of the facility management, like building management systems, they're very old and they have a very unique way of working, and it's getting into that. And sometimes that cost is very prohibitive to get the right code so that if there's a problem. It's never a problem when everything's working. It's a problem when something goes wrong, water stops flowing, and then what do you go next? How do you deal with that event, not when everything's going right?
Hey, just a quick question since you brought it up. You guys do a good business in containerized data centers. How much, percentage-wise, how much of that winds up going towards greenfield installations versus you have the ability to kind of, is anybody retrofitting things with containerized solutions right now?
Most of what we've seen so far has been greenfield applications. They're putting very, very rarely is customer say, okay, I'm going to move the servers from here to here. Here's this, we're going to put the largest container customers are some of your largest scale-out vendors, and they're buying, 10 to 20 pods at a time, and they're pushing them out that way as a greenfield alternative.
Same.
Are they mostly in hostile environments or not necessarily?
No, not.
No.
Some.
Oregon sometimes is I live there, I know. Right?
No, Oscar time, man.
Yeah, exactly.
Any questions from the audience?
I'd actually be interested in, for Disney and Facebook, from the hardware standpoint, long-term preservation. So Disney knows about that for 100 years of media. Facebook, you're a little younger, but I know we're all going to want our photos 20 years from now. So what are you guys thinking about some of that, the challenges around preserving data forever in digital cloud?
Sure. One thing I can say, and it's not really from the Facebook perspective, it's already launched into the Open Compute project, but there's a project called Knox, which was started a couple months ago, which is focused on hardware and software solutions for long-term preservation of data. So back in, we had our second summit in New York City, there was a panel and discussion on trying to protect data for 100 years. So trying to develop a standard for 100 years protection of data. And that was focused on what hardware solutions do we need to be able to transfer data from one solution to another from a hardware perspective. But what are the software mechanisms for object stores and things like that to be able to manage data for long periods of time? And what does the physical infrastructure need to look like going from, say, a lot of data being stored in Memcache for photos that might be observed, that have been just placed online, to after some period of time putting them on magnetic drives for longer term storage, to eventually things like low-cost flash or tape or things like that.
So I wish I had visibility into what we're doing at Disney in that. I don't, unfortunately, but now I'm going to find out. Thank you.
I could say from one thing that we've seen, if you look at traditionally you had hardware, they'll do a RAID 5 array. Hey, we're going to save a RAID 5. Then with scale out, okay, we're going to put 2 to 3 sets of the data out there if something fails. And I think one of the keys there is the future of the software to efficiently move that, because the meantime between failure of the drive we try to put them in, we have the less failure rate for the first 5 years, but, one drive is going to make it to that 50-year mark if you look at some of those. So I think it's, if you're looking at 100-year storage, it's going to keep evolving because now, yes, we have flash-based storage, but flash-based is not as cheap as the spindles today. And as that moves on, it's really how's the software going to do that and do it, for, examples in Facebook. It's one part of the free service that goes on there, keep uploading them. But it's going to be that length of time of how it moves.
We have time for maybe one or two more questions. Don't be shy.
So one of the items up there is low power processors or low power servers. And low power processors for servers and some other ideas like specialty engines for particular functions like encryption, decryption, etc. These have been ideas that have been floating around for 10, 15 years, but it never really hit the mainstream. So does anybody up there really see that changing?
Well, I think one thing, just the nice thing about having an open source community is people can throw out ideas like that and we can try them out. So we're actually right now trying to spin up an open project to try to look at actually tangible hardware definitions and prototypes and things like that, both around ARM-based solutions, but also some of the low-power x86 solutions as well.
So I will say from HP's point of view, it's been one of the key tenets that we've been looking at right now. We announced a project called Project Moonshot. And where I see it really happening is, I think where it's failed before is when they try to make this the multi-purpose server one-size-fits-all. And as we've seen, the compute applications use different servers. That is where I really see the beneficial of this, is they're going to say, okay, I want this for web front end, or this might make a great Hadoop, or we can put this HPC node type in there and to move that forward. And I do see that coming around, but you'll never really get this massive transition until you start looking at how the power goes and the applications that run on that, until you start looking at it at a server level basis. And to say, most of the customers that I've heard that when we've talked Project Moonshot, when we've showed them the slides, we show them the technology coming up, and we've talked about Atom servers and ARM servers and this, they say, this is great, but I'm only going to run my new applications on this. I think there's a new application. I'm not going to run my old stuff because it works. And I don't want to mess up what works. Let me start testing this new application here. And that's where I see the real, I don't see it's going away. I see it's going to be there a while, and it's going to have the longevity and the way customers break up the compute.
Couldn't agree more. Some additional thoughts is, we think if you're going with low power type procs, it's important to make sure the application stacks and the operating systems work too. So, one of the things that we're trying to do, at least in working with the software community, is working with the folks at Canonical, working with the Hadoop distro folks like Cloudera, and making sure that their applications run optimally on low power type procs, as well as what they're doing today with the Atom-based processors. So that's a big piece, but again, agree that it all depends what the workloads are. We had a colleague of mine had a conversation before he came in here about what customers are interested in ARM, what aren't, and it's a use case issue. So in the world of Hadoop, makes sense if you're not using it in a real-time function. But if you look at a real-time function where you're streaming data and such, then obviously from a performance standpoint, then you need to do your homework to make sure it works optimally.
So we've actually done this. And discovered that there are the industry for high density low power compute chassis is actually at the point where it's adding value to the enterprise. It is workload specific. Two comments on that. One is that we actually took existing applications and threw it on testing, of course, not just dumping it in production. And we found that on an Atom platform that we could trade off about 1.5. We'd have to the mapping was about 1 Xeon processor to 1.5 Atom cores, and the TCO savings was quite significant. Those chassis are starting to advance and now allow for the swapping of different types of chips and memory configurations and that kind of stuff. And so from my perspective, it's definitely finally there. Right? You know, it remains to be seen how much the industry adopts it.
Sorry, I don't want to be the only one who didn't contribute it. But one point I did want to sort of add, which is, I think there are two questions that you sort of embedded in there, which are great. One is about low power, and the other one is sort of application specific. And I think that they are a little bit, different. I think there's definitely a trend towards low power. I think the question becomes is when people do things that are application specific, the threshold jumps, so the escape threshold for new technologies. I've been through the pain of trying to get people to adopt something that required a software port or very specific application enhancements, and you have to show them something that really is super compelling to get them over that sort of escape philosophy. So there's sort of two elements to what I think you have.
Well, who is using GPUs to do the heavy lifting now?
Most of the customers that I've seen have been on the HPC side of the house. And that's basically because they're willing to take the time to recompile, to write the code so it ports over to a GPU well, and do that. I really haven't seen too many. I mean, HPC has been in the core customer base of that.
Yeah.
Anything in the financial industry?
Everyone in violent?
Well, but when I talk HPC, there's HPC elements in the financial industry where they're going to be running a cluster with InfiniBand and running this. You have oil and gas. Love my oil and gas from Houston. They do a lot of great when they're doing the seismic mapping. They're really doing that. That's where we really see the GPUs being leveraged.
We're also seeing life sciences, pharma, anything with intense type computation.
One more question. If no one has it, I'm going to ask about solid state storage going mainstream and what that means. And then we can let you all go.
I think it's now. I mean, there's obviously certain applications where if you have a tremendous amount of writes, you have to be careful about the proliferation of it. The economics are coming together. We've seen cases where people in CDN networks or a whole bunch of data-driven applications are seeing great acceleration as a result of it. It drives IO throughput through the roof. It's amazing to me how much some large scale-out customers are actually spending on flash devices, and today it's solid-state drives, but it's really going to start moving more and more into some sort of cache elements, and eventually, a memory substitute.
But in a tiered way.
In a tiered way.
Anyone else? Thank you very much. Really appreciate it. Great.